Okay, we can have a specific rule or pattern in the sequence that we are adding 3 on each term in the sequence. So if we're going to write a rule or a pattern in the sequence that we have, we will be having an is equals to 3 times n, wherein n stands for the position, the relative position of and 3 is the pattern itself that we have in a sequence. So that's how we write a rule or an equation for a sequence. So for example, we have sequence an equals to 2n plus 3, and we're going to identify the first 5 terms of our sequence. So in the problem, the term is not given, but the rule of the sequence is given, which is 2n plus 3. So since we're solving for the first 5 terms of our sequence, we can change the value of n to the relative position that we are solving. For example, we're going to solve for the first term. So that will be stands as a sub 1 since we're solving for the first term. Just the equation 2n plus 3. So n is equal to 3. So we will be having 2 times 1 plus 3. So the first term will be equal to 5. So that is our first term in the sequence that we have. And if we're going to continue until we reach the first 5 terms of our sequence, we're just going to change the value of n to the relative position of the term that we are solving. Let's say we're solving for the second term. So it will be 8 sub 2. So the value of n is 2. So 2 times 2 plus 3.
You're killing him. You're killing Teacher Jeremy.
2n times 2 plus 3. So we have 7 as the value for our second term in the sequence. Proceed with the third term of the sequence. So we have 2 times 3 plus 3. So we have 9. And for the fourth term, we have 2 times 4 plus 3 equals to 11. And the last, the fifth term, so 2 times 5 plus 3, which is equal to 13. So the first 5 term of the sequence with a rule of 2 n plus 3 is 5, 7, 9, 11, and 13. So that is the first 5 terms of our sequence. Okay. As you can see, you're just changing the value of the variable n to the relative position that you were solving. Anong position or anong term ang sinosolve in your sequence. But what if we are solving for a specific term? If we are solving for a specific term, we call that as an arithmetic sequence. When we say arithmetic sequence, arithmetic sequence is a sequence whose consecutive terms have a common difference. So that's what we mean by arithmetic sequence. They have common pattern or common difference in the given sequence that we have. For example, we have the sequence 3, 5, 7, 9, 11, and 13. The common difference or the pattern in the sequence that we have is adding 2. To solve for the common difference of your arithmetic sequence, you're just going to subtract the consecutive terms in your sequence, which is 5 minus 3 is equal to 2. At kapag merong naibang difference or common pattern in the sequence that we have, that is not arithmetic. Pero pag may naiba. So that's how we find for the common difference of our arithmetic sequence. You just subtract the consecutive term of your sequence. We have the formula that we can use for us to be able to find a specific term of our sequence para hindi na natin, for example, if you're solving for 20th term, if you don't want to continue the sequence, we have the formula that we can use to proceed in finding the 20th already. So we have this formula, which is you can use the formula to find a specific term of our arithmetic sequence, which is an equals to a sub 1 plus n minus 1 times d, wherein a sub 1 stands for the first term of our arithmetic sequence, n stands for the relative position that you're solving, and d stands for the common difference. So that's the formula of arithmetic sequence in solving for a specific term. Since if you're solving for a sequence 100 term, para hindi na i-continue yung sequence until you reach 100 term, you can use this formula. For example, we're going to find the 14th term of the arithmetic sequence for 7, 10, and 13. So that is our arithmetic sequence. And we need to solve for the 14th term. Kung ayaw gamitin si formula, you can do so. Just continue this sequence until you reach the 14th position. But to make it easier, you can use the formula that we have for arithmetic sequence, which is an equals to the first term plus n minus 1 times the common difference. Okay. In the formula, the given or the value that we need to solve for the specific term is the value for the first term, the value for n, and our common difference. In our arithmetic sequence, the first term is 4, and the relative position that we are solving is 14. So our n is 14, and the common difference is 3. Since 7 minus 4 is equal to 3. So substitute the given value in the formula that we have. So 4 plus 14 minus 1 times 3. So we have 4 plus 13 multiplied by 3. So we have 4 plus 39. So the 14th term of our arithmetic sequence is equal to 43. So that's the 14th term of our arithmetic sequence. Kung ayaw gamitin si formula, kung gustong pahirapan ng sarili, pwede naman. It's just going to continue if that is what you want. If you're going to continue the sequence 4, 7, 10, 13 until you reach the 14th term, we have 16, 19, and so on. You can do that. But it will consume a lot of time if that is what you're going to do in continuing the sequence. Okay na, for this example, can I clear the screen? So for example, we have this problem. We need to find the 16th term of a sequence with a first term which is equal to 1.5 and a common difference which is 0.5. So it's already given in the problem. The first term is 1.5 and the common difference is 0.5. So we just need to substitute the given value in the problem using the formula for our arithmetic sequence. So A16 is equal to the first term, which is 1.5, plus n, which is also 16, minus 1, times the common difference, which is 0.5. So 1.5 plus 16 minus 1 is equal to 15 multiplied by 0.5. So 1.5 plus 7.5. So the 16th term of our arithmetic sequence is equal to 9. So that's the 16th term of our arithmetic sequence. Okay, now can I clear the screen with this example that we have?
Okay, so
position. But now what we're looking for is the position of a term with a value of 301. So we're going to use the same formula, which is an equals to the first term plus n minus 1 multiplied by the common difference. Okay. What we're solving here in this problem is the value of n, which stands for the relative position. Our an is equal to 301, and the first term of our arithmetic sequence is 4 plus n minus 1 times the common difference, which is equal to 3. So 301 equals to 4 plus 3 times n is equal to 3n, and 3 times negative 1 is equal to negative 3. Combine similar terms, so we will be having 301 equals to positive 1 plus 3n. So 301 minus 1 is equal to 3n. So we have 300 equals to 3n. Divide both sides by 3. So the position of the term that has a value of 301 is 100. So that's the position, the relative position of a term with a value of 301. Okay. Another example wherein we can use the same formula, but what we're solving is the first term. Given that we have the common ratio, we have the first term, and we have the value of a specific term in our sequence. So for example, we're going to find n. If an is equal to 633, and the first term is equal to 9, and b is equal to 24. So the same of what we have a while ago. What we're solving here is the relative position of a term with a value of 633. So given the formula for arithmetic sequence equals to the first term plus n minus 1 times d, our an is 633, and our first term is 9 plus n minus 1 times our common difference, which is 24. So 633 equals to 9 plus 24n minus 24. Combine similar terms, we have 633 minus 9 plus 24 equals to 24n. So 633 minus 9 plus 24, which is equal to 648. Divide both sides by 24. So the position of the term that has a value of 633 is equal to 27. So n is equal to 27 in our arithmetic sequence. So let's say we're solving for the first term using the formula that we have. For example, we have given an arithmetic sequence with a 15 is equal to 38, and the common difference is negative 3. Find the first term. So what we're solving here is the first term of our arithmetic sequence. We have the value for the common difference, which is equal to -3. We have the value for an, which is equal to 38. And we have the value of n, which is equal to 15. Since that is the last given term in the sequence, what we're solving is the first term of our sequence. Using the same formula that we have, which is an equals to the first term plus n minus 1 times d. So 38 plus first term, 15 minus 1 times the common difference, which is equal to -3. So 38 a sub 1 plus 14 times -3. So we have 38 equals to the first term plus 14 times -3 is equal to -42. Combine similar terms. So 38 plus 42, the first term of our arithmetic sequence is equal to 80. So that is the first term of our arithmetic sequence. So as you can see, using the formula for the arithmetic sequence, you can be able to solve for the specific term of the sequence. You can solve for the position, the relative position of the sequence, and you can also solve for the first term of the arithmetic sequence that we have. Let's try another example that we have here. So for example, we're going to solve for the common difference. Given that the first term of our arithmetic sequence is -6 and the 29th term is equal to 20. So what we're solving here is the common difference. So we're going to use the formula, the same formula that we have, which is an equals to plus n minus 1 times d. The value of an is equal to 20. That's the 29th term. The first term, which is equal to -6. And the value of n is 29. So 29 minus 1 times the common difference that we need to solve. So 20 equals to -6 plus 28d. So 20 plus 6 is equal to 28d. So 26 is equal to 28d. Divide both sides by 28. So the common difference of our arithmetic sequence is equal to 0.93. So that's the common difference of our arithmetic sequence. So whatever what you're solving for the arithmetic sequence, you're just going to use one formula, which is an equals to a sub 1 plus n minus 1 times t. Whatever term or whatever part of the sequence you are looking for in the given sequence that we have. So let's proceed in writing an equation for the nth term of an arithmetic sequence. So for example, we have a sequence 8, 17, 26, and 35. In writing an equation for a specific sequence, the only thing that you need is the first term and the common difference. That is what we're going to need to write an equation for our arithmetic sequence. Looking at our sequence given in the problem, which is 8, 17, 26, and 35, the first term is equal to 8, and the common difference is equal to 9. Since that is what we have for the value of the first term and the common difference, we can be able to write the equation using the formula an equals to the first term plus n minus 1 times d. Just substitute the given value of your first term and common difference. So we have an equals to 8 plus n minus 1 times 9. So an is equal to 8 plus 9n minus to 9. So the equation of our arithmetic sequence is equal to 9n minus 1. So that is the equation of our arithmetic sequence. So what you only need in writing for the equation is the first term and the common difference using the formula for arithmetic sequence to write an equation for a given specific sequence that we have. So let's have another example in writing an equation. So for example, we're going to write an equation for our arithmetic sequence, which is 3 For example, that is our arithmetic sequence, and we're going to write an equation to represent the nth term of our arithmetic sequence. So what we need to write an equation is the value for the first term and the value for the common difference. The first term of our equation or our sequence is 3, and the common difference is 4. So since we have these two important value that we will be needing to write the equation, we can now proceed to solve for the equation of our arithmetic sequence using the formula an equals to the first term plus n minus 1 times d. So we have an, our first term is 3 plus n minus 1 multiplied by 4. So an is equal to 3 plus 4n minus 4. Combine similar terms in the expression that we have. So the equation of our arithmetic sequence is equal to an equals to 4n minus 1. So that is the equation of our arithmetic sequence. Okay. Question in solving for the arithmetic sequence. Okay. You try to write an equation for this arithmetic sequence. Okay. So let's say we have this sequence. Write the equation for the nth term of the arithmetic sequence 5, 7, 9, and 11.